We are going to follow, as you can see, there's a lot of diversity between our conferences. Thank you very much for this explanation of the German architecture. I'm now going to introduce Ammar Khammash. I was lucky to follow one of his workshops. He gave a conference to students, which is going to be similar, I imagine, to what he's going to tell you today. Where is he taking us? You'll be surprised. Well, he's leading us towards architecture. He's from Jordan and was trained in the US. He is very singular. But the Global Award was created to support architects who are isolated. Ammar is singular because he's not only an architect. This 100th anniversary of the Bauhaus is the opportunity to welcome a man who's also a painter, photographer, musician, who has a doctorate in ethno-archaeology, which was a turn in his personal path. He's also a botanic and a geologist, and his university was Jordanian desert. So I invite you to go and see his platform, his website, where he exposes his discoveries and his works. He is also singular because he was first trained in isolated villages of Jordan to document vernacular architecture, to restore this heritage, cultural and natural, because everything is linked according to him. This reminds us of Wang Shu, of course, who after his studies spent 10 years studying and restoring heritage architecture to find and rediscover a Chinese culture of architecture that had been forgotten and that was no longer taught. Wang Shu would have explained that he did not want to join the market of architecture as it had become. The posture of Ammar is also explained in this quotation that says, "Our work is linked to economy, but only insofar as we borrow or destroy other parts of nature to produce architecture." The trend of architecture is following the opposite path. In the Jordanian desert, bulldozers are illegally extracting marble, leaving wide holes. Architecture has become a crime since we've been extracting for Gulf countries, when we should be learning how biology and nature works if we want architecture to survive. Ammar, you have the floor.
Thank you for this wonderful chance to be here in Paris. I'm actually the product of this landscape. We are very, very lucky in Jordan because this country is actually sitting in a hinge, in a connection point between all of Africa and the rest of Asia and the Middle East. So this context has actually created everything that I've been doing. I'm a person that has been collecting the understanding and knowledge and reading of the landscape from many, many different layers of disciplines and even scientific expertise. For me, Jordan has been my university, my school. I studied in Lafayette, Louisiana, architecture, and then I came back to Jordan in the mid-'80s and studied anthropology and archaeology, and then continued on my own to understand geology, geomorphology, paleontology, botany, and so I'm all over in the landscape, just understanding how nature takes a decision. The very, very complex, and nature, by the way, the landscape is not cut like universities do cut it into different disciplines. Nature is continuum. It's you don't know where biology starts, where geology starts, and where archaeology starts or stops. So it's all together, and only for academic purposes, we actually cut it to pieces. And the problem is that universities and academia forget to put it back together. So I am actually always on the fence. I don't like to be in any of these farms. And I'm not even in the architecture farm. I'm not really in the architecture, typical architecture practice. I'm always on the edge. I'm always actually trying to do overlap between different areas of knowledge and challenge this knowledge. So this landscape I understand so well. You know, I go in a section like this, I walk it, I'm equipped with the entire survey of geologists and paleontologists, and I'm taking a section, a sample of all the fossils. So I understand how nature acts, what happened here. You know, this is, for example, marine sedimentation, and we're talking about like 20 million years of section, so I understand all the different animal species and what happened, and if there's mass extinction, which we do have in the section, by the way, called the KT boundary, you know, the extinction of the dinosaur, 64.5 million years ago, and it's in that section, so I understand what happened, and for me, this is the source of inspiration as a designer, to understand material and to understand human added value in the past, and currently human augmented brain. I mean, we have given up on our biological brain alone. We can't function anymore, purely biological brain. So we have now a very, very fast-moving and to some maybe even scary way of pushing materials and tinkering and playing with physics and chemistry and virtuality. You know, the whole line and membrane between physical world and virtual world is getting much thinner. Here, for example, we have amazing examples in Jordan. I mean, Jordan is really an open book. It's a library that is endless. And here we have an example of what is called kites. Kites are like, they're huge trapping apparatus for gazelle and animal. Some of them can date back to about 10 or even 15,000 years. And for me, it is so interesting how humans actually use the landscape by adding a structure. And it looks almost like a tensile structure a little bit. But, and I like to compare it to this kind of approach, what spiders do. They're using a thorny bush or thorny branch and just doing a tensile structure to it. So how do I apply this as a designer? It's a very interesting thing that keeps really my brain never resting and pushing into ways of reading the landscape and then applying it directly or sometimes unconsciously, in fact, in my design. Of course, here in archaeology, we have examples of those rock art that shows people chasing animals into these huge hunting apparatus, which are called kites. They can be a couple of kilometers long, and we have hundreds of them. They were never fully counted. Some of them are already now sinking in total contemporary growing towns. This is the northern Azraq town. I'll try to go back. Anyway, it's, so you could see a kite and then the modern. The Jordanian desert actually has a lot of interesting phenomena, and it makes me also look at examples of how the geology is creating something we call desert pavement. It makes textures on the ground, and then that desert pavement is also creates another phenomena called desert luster or desert varnish, which is a nice shine that happens on the surface of the flint. I'm also interested in the morphology, how nature makes shape, you know, how nature forms shape, differential erosion, and here you have sedimentation that has eroded differently, creating a certain volume, and then the whole speed of humidity in that structure. So what about architecture that change can we design a building that ages nice? Can we design a building that erodes, actually? And self-design. But again, not very direct. This is very important. I don't copy or nature directly, but I get some hint of the process, if I can design a process, not a product. And again, you know, issues like biology in the marine biology and how it leaves trace fossils, flint, how does it break, and what happens inside the flint, which is an amazing material, difficult to use for architects, but it's one of the first added value for material for humans. And in Jordan, we have those amazing flint implements that they can be very, very sharp, that even in modern medicine, some surgical equipment still uses flint till now. But also in Jordan, I started to explore the sound properties and quality of flint. About 5 or 6 years ago, I started to actually listening to the flint stones, and especially those that are spreading for miles and miles and miles, and trying to actually understand, is there any hidden scale or you know, a hidden, let's say, scale which is not the typical chromatic scale that we have now on a typical piano or a typical instrument. So I came up with a long-lasting, it will never end, by the way, research that is actually providing new scales, which is non-chromatic. And so we go into mathematics and the whole issue of, let's say, for those musicians, cutting from an octave C1 to C2, or from B to B or F to F, instead of 12 notes and half notes, I'm cutting into many other, with new mathematics. So the whole, those who know about music, we cannot use MIDI here anymore, so we have to create new mathematics altogether. And that project actually now is working with recording and analyzing Bedouin songs, and especially tribes that are intermarrying and actually create a genetic pool. And I'm trying to understand if they have a common tribal note and maybe also a common tribal scale. So we can go and use any ethnic music, listen to it, and then play it on these scales, alternative scales, which is not the typical chromatic, and is not microtonal. I don't want to go too much into music because it gets too technical, because microtonal music in the West is cutting the chromatic 12 notes into half notes or quarter notes. So it still goes back to the 12. But here I'm working with 13, 14, 15, you know, new mathematics altogether. Also, the whole issue of what makes the sound, is it material or is it form? And here we have the first upper 3 Jordanian flints copied in 3, keeping the shape, so they're really copied exact shape, but into aluminum and brass. And then what happens to the sequence? And what happens here actually is something we call transpose. The music is the same, but it goes down a couple of notes. Again, I'm really interested in patterns in nature and the origin of these patterns and how the process that creates a pattern, including things like those ripple marks of ancient waves in the shallow sea, some of them as old as 350 million years. And you can see that motion of the sea and the bottom of, but also the whole mathematics of non-decimal math, if you will. You know, what are other mathematic process or geometry that we can really not force it to go through the typical human math, but actually construct a parallel math models that make us read better. For example, in a lot of my projects, I let the workers do something very, very simple from very simple material, and then surprise them by telling them we're not plastering. So this is a bottom of a staircase, and for me, it's like a fossil. In fact, all architecture is a trace fossil of human behavior. And I like to do this a lot, where I under-design. I surprise the contractor. I tell him, okay, now you stop. So for me, the process is frozen in time. I'm also interested in the self-coloring of geology and experimenting now with self-coloring facades and buildings, where I'm adding powdered copper or powdered iron, and then with a certain humidity into the faults, and where it actually grows into a building. So the building changes color very slowly, like geology does. And here you have, for example, a fault, a very small fault in the very lower rocks of Petra, and you see this copper that is growing into that fault and doing a fantastic turquoise color. Again, I mean, geology has given me a lot of examples. It's this amazing designer that works with chemistry, physics, and biology together, and time. And for me, this is even structural and other aspects of geology. And slowly, I'm actually coming up with this whole notion of, instead of biomimicry, there's something that I'm calling geomimicry. And what happens if we look at geology, which, by the way, includes a lot of biology. I mean, in geological formation like this, these rocks are formed by clusters and chunks of organic matter. So sedimentation is never purely chemical or physical. It's chemical, physical, and a lot of bacteria, a lot of biology, actually, and organic matter. So I'm again interested in time and sections in the sea, Dead Sea, what we call the sand formation, which is like a book, and you can see all the seasons of dry weather. And so the whole issue of paleoclimate connected to dendrochronology, which is dating by tree rings in archaeology, in the Dead Sea and the tree of the Eastern Mediterranean. For me, again, botany in Jordan is a major interest, and I'm actually a person who's actually studying the limits of habitats of certain species as an indicator species. So in global warming, what happens to a limit of black iris? Is it shrinking, or is it moving to another, not invading, spreading to a new landscape, or is it retreating? Or the very, very last end of desert tulip in just north of Wadi Rum, and you have this very rare tulip called Tulpa polychroma, multicolored tulip, which is the very, very last tulip of, let's say, Eastern Turkey and the Levant. Or this iris, which I discovered for the first time in Jordan about 17 years ago. And it's not new to science, but it was new to Jordan then, Iris bismarckiana called. Or a very important thing for me also as an architect is how plants, desert plants, manage water harvesting. And so the architecture of desert plants, what do they do? How do they behave? And plants in the desert do amazing stuff. Like this tulip, the whole issue of the of this leaf like this, the jaggedy, or the the one that has this morphology to slow down the air and thus prevent evaporation of the water. This is one of my favorite plants. In fact, the only scientific paper that I've published in the Belgium Royal Botanical Garden a couple of years ago is about this plant, Rheum palestinum, the scientific name. And it does something very, very weird. It's a rhubarb, it's a desert rhubarb, but it actually traps water vapor, and it traps, it's like a vapor trap. It works by condensation of rising vapor from the ground. So it's a very, very strange and for the first time identified behavior in botany from this plant. And this is the paper that was published describing that new behavior, which is very architectural, because I actually use architecture modeling to also discuss the whole issue of self-shading and how can we actually later use something like that for desert architecture that does harvest of both fog and rising humidity from the ground. Which brings us to another area of texture, textile and fabric possibilities as a harvesting tool. Of course, the other very exciting thing in Jordan is Petra and the Nabataeans, and that whole classroom, open course, if you will, of how the Nabataeans reacted and took decisions in that amazing sandstone. And we have thousands and thousands of monuments that are there, ready for somebody to actually go and read them properly, understand them properly, and also learn where to stop as an architect. You know, nature here has provided this rock, and then Nabataeans 2,000 years ago made a staircase, and they knew exactly where to stop. You know, so that whole idea of found object, you know, as if you find something and you do very minimal addition, and then you gain the entire product, which you really can't design. Also, the whole idea of looking into the human touch, and now I'm slowly talking to universities to do some research, like PhD students who can actually take some of those ideas and go and look for fingerprints into the plaster. This is a plaster of a cistern in Petra, and I'm interested in genealogy, and if we can know if this is all done by one man or one family by comparing fingerprints. Of course, the Nabataeans are amazing people. They were doing 2,000 years ago pottery that is less than 1 millimeter thick. So this thinness eggshell pottery, if would have came to Rome, and which it did, by the way, it was so shocking. It's like, you know, equivalent to an iPhone right now in terms of technology. And those plates are about this big. Also, what happens in extraction, you know, in Jordan, you'll be walking in the middle of nowhere, and you find this Roman quarry, and the morphology of the left, what is left after removing material for architecture. You know, for me, architecture is a sin, generally, because we're really going and taking. It's always about extraction. It's all about, you make a building and there's a big hole somewhere else. So I'm more interested in the process, so I always look at what happens when a building is built, what happens in the extraction quarry, you know, and what is left there. Also, cases where you see in time, like rain that is cutting, almost like a laser cutter, if you will, and you can see the direction of, and this is an Umayyad Islamic monument, and you can see the rain marks after 1,300 years of rain, desert rain, showing this beautiful product. As a painter, I actually use my time when I paint to actually understand. You know, painting is looking, and art is like a checklist of understanding a landscape. So I sketch a landscape, paint a landscape, so I understand it deeper. And I'm really interested in the anatomy, in the skeleton underneath, because if we look at a landscape, we always look at the skin, but what happens in the bones of the landscape underneath the structure of it. In many times, I'm actually designing a building according to an available material. This building for a friend of mine is not yet built. We're collecting, it's a private art center, and we're waiting till we gather enough funds to start it. And it's actually based on the idea that I'm taking all the extra stone material from stone workshops, and we get them for free. So all we pay is the shipping, and those materials have been the extras, so they've already polluted, you know, the environment, and they're only now causing a big pile of stones, and I just go there, collect them, and also design in a way that there's a lot of randomness, so the contractor or the even worker, simple workers, could actually use any stone. I do very minimal guidelines for them and give them that, result, if you will. Again, the beauty about Jordan that we have this fantastic library that is very little known, all these hidden places that have stunning, contemporary, almost modern examples like this one. And that whole idea of what brings spirituality or what brings the power of a place that doesn't age, not just physical aging, but also doesn't age in terms of its impact on us. This is just a very simple room for shepherds in a place near Karak, which is south of Amman. And the whole idea of what makes form. I mean, this guy actually is preparing a bread for shepherds in the Karak area. And it's an amazing bread that looks like just a piece of stone and is baked by just burying it. So the process of this building I designed and built, in fact, about 28 years ago. It's in a reserve in the southern part of Jordan, not far from Petra, and very, very basic. Just use local builders and local contractors and materials. Another project is actually in Wadi Araba. It's halfway between Dead Sea and Aqaba. This building is using stone, like thin stone slabs to shade the elevation. So in the summertime, the sun is more vertical and you have almost full shading. And what happens with this elevation like this is that it's changing by the time of the day. So it actually gets fully shaded. In the morning, it has more sun. And in winter, it gets more sun because the sun arc bends downward. This is it's called Wild Jordan. It's a building in Amman. And it's one of the very, very few buildings that normally a building has 4 elevations, and with the roof, it's 5 elevations. And this one has 6 elevations because you can see the bottom of it. But the idea here was to allow the ecology and plant, the vegetation cover to go underneath the structure completely. And when I go back to Jordan this summer, I'm designing a 14 or 15 room hotel in the legs of the building below. And it's going to be recessed in the back and maybe out of wood mostly. So it's like as if there's another architect that came after 20 years, maybe 23 years now, and added more functions to it. And this is the presentation I did for the client then, without using, before the AutoCAD and all the 3D modeling, just a simple watercolor. Another building I designed for Columbia Center from the US. They were trying to do a center in Amman for education. It's the line below here. This building structurally is very interesting. It wasn't built because the municipality didn't give enough leasing time for the Columbia. But this building is hanging on the geology like on huge nails. And the nails were huge concrete nails, modeled a little bit from bones of flying birds, from paleontology of flying dinosaurs, Pterosaurus. And the building is actually suspended away from the geological cut of the mountain. And I've taken the permission then of the mayor to actually dig at a 30 degree below the street, so where the foundation is outside the property. So it goes almost like hanging a sculpture away from the wall. And because I wanted the vegetation behind it to actually keep growing, a lot of fig trees were just growing from the cliff. But also, you know, I go all the way to the details, some very, very simple, just a sink in a, you know, made by the local contractor or simple workers, just simple concrete. And again, this is similar, flying away from the wall, made out of very basic and this is the center in a hiking area in the southern part of Jordan, and the 3D modeling for it, which really plays a tricky symbiotic relationship with the cliff. And this is while construction. And you know, I design things to be built by the simplest of contractor. We really, you know, take anybody from the local community, show them how to do it, and here, while construction with a very, you know, massive cantilever. Another structure made from just very simple galvanized plates on a big dome that spans 20 by 20 meter, from very simple reed bar made by local blacksmith and welded on site. And this building actually, it's very interesting now because you walk in and you have all these sheets of sun hitting, you know, slicing the people working in it. And I'd like to go back and do a piece of choreography or a performing art where I'm dressing people with the same grid on their uniform, and then let's see what the two grids work together. A model done for a bridge to tell the contractor how to do the shuttering. This bridge is a masonry bridge, and this is the time when the contractor is preparing the form. And the thing about it is that it has no foundation, like right here. It actually sits on basalt pillars, but I understand I analyzed exactly the direction of the basalt pillars to give it load without any anchorage. It's just resting by pushing. It's a 50-meter span masonry bridge. And here it is when it's finished. It's now looking like that. And now we go back another 30 years into the Church of the Apostles. It's a Byzantine church, and this was a project financed by the American government. And the idea was to do labor-intensive, to employ as much people as possible. So very little material. We took the extra stones from stone cutting workshops and employed maximum number of people. So the whole design changed. So the building is designed to employ a lot of people. We call labor-intensive architecture design. It's designed to employ people, and in this way, arches make a lot of sense. Arches here are 16-meter span, and they hold inside a Byzantine mosaic, which is 5th century mosaic. And we couldn't lift completely the mosaic, so the very bottom of the arches have hooks that are waiting for one day if they want to actually remove the mosaics and then do tension, extra tension. I don't think it needs. This building has been built in 1983 and is doing perfect since then. It looks like this right now. So sometimes, you know, I go extremely simple, extremely primitive, and extremely almost like Middle Ages if the site needs that kind of solution. This building is it's called the Royal Academy for Conservation of Nature. It's actually an academy that teaches landscape management, if you will. And it is built on a quarry that was abandoned in the 90s, and the face of the quarry, which was, when it was abandoned, was exactly the front elevation. So what I did, I just picked up the line and took it to the office, sent the surveyor again, and drew the line on the site with the marker, and then the surveyor picked that line, brought it back to my office, and that was the front elevation. So whoever the driver of the bulldozer in the 90s, when this quarry was abandoned, he never knew that he was designing a facade of a building, because I just, followed my facade on that leftover of the. Because for me, I like very much nature when it's wounded. The cut in nature is so beautiful because you see the bones, and it's much nicer to me than pure nature. And this building has the client first wanted me to build that center inside the reserve, and while driving to the site back and forth, I said, why do we add a new wound? Why do we add a new cut? So I went to the client, the Royal Society for Conservation of Nature, and I said, look, I'm not going to do the building in your site. If you don't make it in this site, find another architect. So sometimes now, and that's the beauty about this award. I can do more of that. I can say, I start to be more courageous and write the scope of work, for a better product. So. And here we're trying to toy with the whole idea of pushing material to a zero edge. This is a very simple traditional construction of just leftovers of the quarry stones, but then we took the cornerstones to the cutting factory, and we cut them into 20-degree, almost knife-like edge. And I noticed people come to this building, and they look at this edge, and they do like, it's like Photoshop. They can't understand how this. It's a thick wall. This is a 80-centimeter wall with a straw in it, straw bales, as part of the insulation. But it ends with a knife sharpness at the edge, including even these louvers out of concrete. And a lot of stuff like that I do like a surprise again. When the contractor removed the shuttering, he was so worried because the concrete is a little bit falling apart. And I said, okay, I don't mind, So we always keep a little bit modesty. I think the problem now with architecture that we are losing simplicity and modesty, and buildings are becoming too much bullying the society by trying to be too smart. And they don't have to be, They have to be safe, they have to be nice and modest, This is how the building ends at the forest side, and it's not, this elevation was never designed for any beauty or any of that. It was designed to minimize foundation. So we needed an outdoor terrace, and I kept with the structural engineers not to calculate structure, to calculate quantity of material, talking about lighter buildings and more usable space. But what is the maximum usable space and area with the lightest amount of foundation? And that gives me this kind of solution where trees have discovered it way before, very minimal footprint and very big crown. And the contractor workers were so excited and testing it, and standing too dangerous on the tip. Of course, we don't place railings that far. Normally, we push them back in. So we go to a certain thickness when it's at least like 8 centimeters, and then we put the railings. So the terrace looks like that. But also, I'm interested in how light sounds. How do we, when you have light falling, it's like a waterfall. And I think there's something maybe in my brain, that the brain circuitry that is involved in sound is somehow leaking into the other department of the brain, processing vision and light. So I'm always, when I look at something like this, I always hear the sound of the light, and that is something that may be picked up from geology, maybe from a fault like that. Many times I do things, and then after years, I find photographs that I've taken, and I say, wow, maybe that came from this, It's like when you design, you're not conscious. You really are in a trance. You're in an altered state of consciousness, and which makes it very complex, because the very deep ideas actually are, at the beginning, are not logical, and maybe later you discover maybe some connection to them. And thank you very much.